Astronomy is the pursuit to understand our place in this wonderful and bizarre universe. My name is Jielai Zhang. I'm a Schmidt Science Fellow. I'm an astronomer by training, and my long-term goals are to discover things in the universe. In 2016, the first gravitational wave was measured and observed. This opened up a whole new way to study how the universe changes on very short timescales. Galaxies change over millions of years. However, this new discovery of gravitational waves is all about understanding how the sky changes on timescales of days, hours, minutes, seconds, and even less than seconds. Up until recently, telescopes were built to take very long exposures so that they can see fainter stars, fainter galaxies, fainter everything. If you're taking exposure times that are really long, there's no way you can understand how the sky changes over a second. There is this one strange class of objects that have been discovered in the radio wavelength that we call fast radio burst. A flash of radio light that's as bright as the explosion of a star at the end of its life, but all fit into less than a second. We don't know what it is. It could be explosions of different types of stars, collisions of different types of stars, or even energetic activity in the center of galaxies associated with supermassive black holes. We just don't know. In order to do that, one needs to build new types of observing programs and new software. The software is what led me to deep learning. Deep learning is a method to gather information out of big sets of data, and it's especially suited to getting information out of images. However, the use of deep learning is more advanced and mature in medical imaging. It turns out that our understanding of the structural growth and development of the fetal brain is actually quite limited. It's difficult to take an MRI and it's expensive. That's why there's not a lot of data in the first trimester. Ultrasound is the routine clinical tool used to assess fetal health. And so if we could use ultrasound to image and understand the development of the structure of the fetal brain, then we can map out the entire brain development during gestation. One of my favorite quotes is the following: "One does not discover new lands without consenting to losing sight of the shore for a very long time." And I think this really epitomizes discovery. If you want to discover something completely new, you have to be willing to be in a state of uncertainty, at least for a while, if not for quite a while. I think my biggest source of inspiration is somebody who makes me brave and makes me feel like I can go out and do whatever it is that I want. And that's my mom. You can't do anything new without changing, and she embodies the drive to change and continually better herself. She was the first generation to start going to university in China. She went to a university as far away from home as possible because she had a sense of adventure. This constant feeling and desire to take risks runs deep in my family, and I think that is part of the reason why I like astronomy so much. It really is a science of discovery. But this year at Oxford, I've been able to experience what it feels like to do science that can lead directly to benefiting human health and human life. It's a totally different type of motivation. I hope to build the next generation of telescopes, observing techniques, and software, and help us understand that the universe is full of things that we just didn't expect.